applications, so how to put the satellite network in a cloud. This is clearly a potential breakthrough because if the traditional satellite payloads are not upgradable, the same happens for the conventional satellite networking setups that are characterized by rigid configurations that are typically broadcast-like. So substantially the satellite for networking is adapted. Satellite is adapted for two-way networking because satellite is inherently a one-way mean. For instance, the TCP/IP has been completely redesigned for satellite communications. The terrestrial internet networking protocol is different than the internet networking protocol used in satellite communications. For the latencies, for the different environment, for the fact that the satellite is inherently one way. So can we break this bottleneck in some manner? The answer is yes, theoretically yes, theoretically. Practically, the practical implementation of a thing, but theoretically it's possible using software-defined networking. And a very interesting preliminary work dealing with this topic is referenced here. Notice that the authors are all Chinese. I know that the Chinese government is investing a lot of money to implement software-defined network protocols for satellite. Since almost 5 or even 10 years. So this should be a warning for us because really this technology could be successful. Because they are investing. The Chinese are not investing money for nothing. So the potential advantages are well known. Let's start from this architecture. In this architecture, we have substantially the northbound layer of the SDN that is towards the controller, and the southbound that is towards the applications. The advantages of the SDN for satellite are multiple and very important. First of all, the SDN can solve the critical trade-off of satellite networking protocol between flexibility and controllability. In terrestrial network, the dynamic routing is allowed, but and so we can adapt the routing of the information of the packets to the network condition. In satellite communication, this was not possible due to the fact that the dynamic routing need a continuous control information exchange between the network nodes. In satellite communication, the huge latencies hinder this. But if we have a network controller that manages everything, the control plane in centralized manner, this issue can be solved. Another advantage evidenced by the paper that I referenced before is that the central control properties of SDN allows to easily deploy and update the satellite network configuration. So all the satellites can receive the new the new configuration information from the central controller and could update them without any human intervention. In the past, this was impossible because we should substantially, the control center should, at the Earth, with the man at the control center, should send to the satellite the information about the new configuration of routing, scheduling, and so on. But this is not dynamic, this is not adaptive. Where should be the SDN controller? Typically in a terrestrial gateway, in terrestrial base station, typically. Then the SDN can provide the fine-grained scalability of the network control in order to dynamically adapt in real time the network to the change of traffic, to the change of the environment. And another very important feature is related to the possibility of establishing a planned satellite collaboration. So the SDN controller can make the satellite cooperate together, for instance, in the difficult task of interference avoidance. Now we are speaking, for instance, of multi-beam satellites, or satellites using the same frequency resources in order to boost the capacity, but the problem of the interference is very huge because there is a near-far problem inside the satellite, and the satellite receives the wanted satellite signal can be obscured by some interfering one. And in order to avoid, the solution is not to use a complicated and heavy and computationally heavy algorithm of interference cancellation, but the solution could be to plan the satellite transmission in cooperative manner in order to avoid the interference or to minimize it. But this should be performed only if there is a controller above the satellite network that coordinates the satellite activity. These points were really forbidden dreams for conventional satellite networking. In order to highlight how the SDN can improve the satellite, the performance of the networking of the space segment, I wanted to show you a couple of examples. A couple of practical examples that were mentioned in this paper published in the special issue that I managed in the Electronic Communication magazine. These guys are all from the Space Research Center of Toulouse in France. Okay, the first example is related to the inter-hub handover with site diversity and smart hubs. Why do we need the inter-hub handover? Because the satellite, for instance, a multi-beam satellite, can send information to different gateways, but some of these gateways, one or more, is obstructed by the rain. High-frequency satellites working, for instance, in the Kia band or in the millimeter waves are severely impaired by the rain. there is the concrete possibility that some gateways cannot receive information due to adverse atmospheric conditions. What can we do? The solution is not complicated. The idea is to exploit the diversity. We can send the same information to different gateways, and if one of the gateway is not cannot receive the information due to the adverse meteorological condition, the other gateways can reroute the received information to the obscured gateway through the terrestrial network. It seems a very easy solution, spoken by words, but if you want to implement concretely this arrangement with the current networking protocols, you cannot implement it efficiently, or even you cannot implement it at all. Another interesting example that is a typical state-of-the-art example, the satellite and terrestrial network integration. For instance, if I have a service, it's possible to use the satellite to integrate and complement the terrestrial services. The terrestrial services may be performed by means of a wired network or by means of wireless network. This is one of the trends of the 5G of the satellite 5G. So to use the satellite to integrate and complement the terrestrial service. Apparently, it should not be difficult. For instance, we can decide to send delay-sensitive information through the terrestrial network and delay-tolerant information through the satellite link. Delay-sensitive information is typically voice and interactive video. Delay-insensitive information might be the remote downloading of multimedia contents or the remote transmission of information not characterized by real-time constraints. This is apparently quite easy, but the internetworking protocol have a lot of difficulties in managing different information flows transmitted through different means. May SDN help to solve these issues thanks to the centralized software control? The answer is potentially yes. For instance, in the first example of the inter-hub handover with site diversity and smart hubs, it's interesting to see this application in the multi-beam satellites, as I told you, with potential capacities of 1 terabit per second, but in case of rain, the capacity collapses because some of the beams are killed. If the site diversity is would be implemented in ideal manner, we can obtain very high gains against rain fading. if the arrangement that I've shown to you here, this one, works, we can gain up to 20 dB against the rain fading. So in this case, 20 dB means that we can extend the link availability from 99.9% to 99.999 probably. So you can extend of 2 orders of magnitudes the link availability. But this is in theory. But in practice, practically the inter-hub handover has a prohibitive complexity in the conventional satellite networking because it's very difficult to control the operation. The control of the rerouting information from one hub to another in combination with the satellite networking protocol and with the monitoring of the link is very, very difficult also for the difficulty of communication between the satellite node in the sky and the gateways on the Earth, due to also the latencies and it's a very problematic operation. But if the control of the network is removed by the nodes, satellite, gateway, and it's centralized in a unique software controller, this controller assumes the role of master of this operation. And a specific application, because the SDN works on the basis of applications that are implemented and should implement a